today we're going to build a very simple electric motor that you can build really out of 3 components. Take you about 10 minutes, and I guarantee you once you know how to build it, put it on your desk or put it on the table and just kind of let people watch it. They'll kind of stare at it and say, well, how does that work? Because it looks really neat and it just kind of sits there spinning over and over and over until the battery runs down. So let's learn how to build it. It's very, very simple to do. All you'll need to build this little guy is a AA battery. Go and get a new battery. You'll need some copper wire. This is solid copper wire. There's no insulation on it. It's just sort of bare copper. And you will need a magnet. This is a rare earth magnet called a neodymium magnet. You can find them usually at the science supply store, or you can find them certainly online. Usually just cost a few dollars for a magnet like that. You can type into a search engine rare earth magnet or neodymium magnet and find these guys. So believe it or not, that's really all that's required to build this, and there's many, many ways to build a motor. There's many, many designs for motors, but this is really one of the simplest ones and one of the neatest ones. So we want to go ahead and put our safety glasses on just so we have them, just so we can be safe. And I have a pair of scissors here. These are sort of shears that I'm going to use to cut this wire. So really, again, this is solid copper, and you can sort of see the texture of it, so to speak, how much it bends. I mean, it's very easy to bend into whatever shape you want. So the exact size, diameter, and all that doesn't really matter. You just want to get some sort of wire that you're able to bend. And by the way, this would work if you had some kind of really solid copper wire with insulation on there. It should work. You'd have to make a few modifications to it, as long as you have the copper in the middle. So go ahead and make a quick cut, and then we will just sort of put this off to the side. We don't need that anymore. And basically what you're going to do is you'll just take your battery and your magnet, and you will stick the magnet to the bottom of the battery like that. So that's not going anywhere. And ultimately, what the entire device will consist of is you'll put it on the desk and let it sit there, and this piece of copper that we're about to make is just going to spin around and around and around until the battery goes dead. And we've already built a different type, very similar but slightly different type of motor in this experiment series already. They're both really neat. This one, to be honest with you, I kind of like it a little bit more because you can sort of set it down and just let it do its thing, and just people can just watch it. So what you want to do is take your long strand of wire, and basically you want to fold it in half. So you take it like this, and by the way, there's no hard and fast science to this. I mean, as far as how to build it. There's science as far as how the motor works, but there's no one way to exactly do it, I guess is what I'm trying to say. You'll see very quickly how we're basically building the thing, but as far as like the exact way you fold it, the exact way you shape it, the exact way that you form the thing, doesn't really matter that much. So what you're trying to do is basically make a little point here, and then once you get it into a point like this, you want to sort of make almost like a golden arches out of it, like this. So we're going to turn it upside down, and we're going to bend it like this. Or you could look at it as a bird, you know, a little flapping bird, whatever you want to do. But basically you want it to be in a little point like that, and kind of coming up sort of like a golden arches. Now, the reason we're doing that is because really what you want to do is you want it to balance on top of this battery, the way we have it here. Okay, you want to balance it. And the reason is because it's going to just go around and around in a circle like that. Now, one thing you can help with that, I didn't put this in the materials list because it's optional, but if you just get yourself a little screw, and here in the top of the battery here, if you just sort of push on it very gently with a screw like this, you can make a little indentation. You don't want to do it too much. You don't want to, rupture the battery, but just do a little indentation there, right on the top. And that can help because, like I said, ultimately this thing is going to be spinning around and around, so a little indentation there can sort of help it stay on track, so to speak. Okay, now what we're going to do is, let me go ahead and set it up like this. What we're going to do is have it basically like this. I'll go a little bit higher like this. We'll have it basically like this. Now what we want to do is we want to sort of mark where the magnet is at the bottom. So if we sort of put it there, the magnet is going to be there. So keep your finger there, and what you want to do is sort of bend that in like this, right? You want to bend that in. You want to do the same thing on the other side. And you can sort of see what I'm talking about when I say there's no exact science to exactly how to build these things. You know, it's going to be your own little creation when you're done with it. Right? So if we put it like this, we should have these two little pieces crisscrossing right on top of the magnet. Basically, you're making a circuit where the electricity can flow out of the battery and down through the magnet. And of course, since the magnet's connected to the other part of the battery, it just kind of makes a circuit of electricity like this. Okay, so what we want to do is, as we place this guy on top, like this, we want to be able to touch the top and have the bottom two pieces touch the magnet down here. And we'll let go. And you can see it already sort of started to spin. So you can sort of let go, and you can see it spin and it sort of falls off. So this is the basic motor. You can sort of see it spinning as we do our thing. The only problem is it's really not stable, because since the bottom here is just sort of open, as soon as it starts spinning, a lot of times it's going to fall off, and that's no fun. So what you really want to do is sort of bend the bottom here. If you can kind of see, down by the magnet, what you really want to do is bend these bottom pieces to kind of curve around your magnet and sort of grab onto it. And that can take a few minutes to do. So I've already done it basically right here. And you can sort of see the difference. So here's the one I just created here. You want to kind of curve these two pieces down here. And so that's what I've done in this one right here. You can sort of see this guy curve down like that. So if you do that, then what you're going to have is you'll just kind of, you can see how it's kind of loosey-goosey down here. You can just kind of go and slide it on top and touch it there and let go and see what happens here. And we can see that it is spinning nicely, and it just sort of continues to go and go and go. And that's the nice thing about this motor. It's very simple to build, just takes a few minutes, and you can literally have this sitting out on your desk. If you're a teacher, just kind of have it sitting out. If you're just working in an office environment, just grab it out of your desk, put it out, and this thing's going to continue to spin until the battery's dead. All right, now it's time to try to understand exactly how this is working. And you know, the exact details of how it's working, you could use math, you could figure out exactly how fast it's going to spin, the direction it's going to spin, and all of that. And I'm not interested in really giving a math lesson right now, but what I am interested in doing is trying to teach you basically how it works. So what you have here is very simply a wire connected to the top of the battery, the positive terminal of this battery, and then you have that wire coming around and taking the electric current down and dumping it into this magnet. And now you need to know also that this magnet conducts electricity. So when the electricity goes into this magnet, it's allowed to go straight back up into the battery. So you've completed a circuit on both sides really, and you've allowed the electricity to kind of come out and back and come back down into the magnet. Now, what this does is very, very important, is really the key to the whole thing working. The one thing you need to know how any magnet or any motor works, any kind of motor that turns when you put electricity into it, they all basically work the same way. Motors work because of one fact of nature, and that is the following. If you have a magnetic field, and we have a magnetic field around this magnet here, if you have a magnetic field, then if you have an electric current flowing through a wire in that magnetic field, then there's going to be a force on that wire. Okay, that's always going to happen. That's something that you learn when you get into physics classes and things like that, and that's how all motors work. And I'll say it one more time. If you have a magnetic field and then you have a current like flowing through a wire that's placed inside that field, there's going to be a force that's going to pop up and act on the wire. Right? Now in this particular case, the direction of the magnetic field, that's all invisible by the way, you can't see the magnetic field, but it's here. The direction of the field and the direction of the current line up in such a way to cause a force to want to push this guy, which direction? In the clockwise direction. So the current is flowing down through and going in this direction. The magnetic field is down there around that magnet, and the two directions of the magnetic field and of the current tend to put a force on this side of the wire, pushing this way, and on this side of the wire, pushing this way. So what you get is a net turning effect. So the force on this wire is going that way, the force on this wire is going that way. One thing that might be kind of nice to see is sort of like a picture. This magnet that's on the bottom is basically like a cylinder like this, right? And you can't see it, but there is a magnetic field that's coming around there. So the direction of that magnetic field comes from the top face and kind of goes invisibly out and kind of comes back to the bottom face, and it has some kind of direction to it. That's why I have arrows here. So the magnetic field over here kind of circulates like this, right? So, you know, I could keep drawing lines, but I don't want to clutter up the drawing. Basically, you have, you know, going from the top, coming down to the bottom, going to the top, coming down to the bottom, and it's in 3 dimensions. So no matter how you look at it, there's always an invisible magnetic field coming from the top and going to the bottom. But mainly what I'm wanting to show you is that there's a direction to this magnetic field. There's a direction to it. If you take the magnet and flip it over, the direction of all these arrows is going to be backwards, right? You can kind of just sort of see that. If I turn the magnet upside down, then the arrows are going to basically point the other direction. So what this means is that if in this configuration, if when we have the magnet like this, if the force lines up to want to turn this guy in the clockwise direction, what do you think is going to happen if we flip the magnet over? Right? So let's first of all look at it exactly the way we built it, like this, and we can see that the motor wants to turn in the clockwise direction. All right? So what we'll do is we'll flip the magnet over, that's all I've done, put it back into place. And basically what we're doing is that the electricity is still flowing in the same way. The electricity is still coming out of the top of the battery and flowing down towards the bottom and going into the magnet in the same way. The electricity is doing the same thing, but the difference here is that the magnet is flipped over. So the magnetic field is flipped over, and that's causing the force on these wires to be reverse of what they originally were. I'm Jason with ScienceAndMath.com. I hope you've enjoyed this segment where we've learned how to build a very simple motor, probably one of the simplest motors that you can build, that you can just build it, put on your desk, and sort of gingerly watch it spin around. Now I'll tell you, if you spend some time and get the bottom of it looking just perfect and get some pliers out and shape it to the circumference of that magnet down there, you'll get a perfect fit, and you can just let it watch go even faster and faster. It's very, very simple to do, but it does take a little bit of time to get that bottom exactly correct so that it's always touching that magnet. So spend some time, play around with it, but even if you don't do that, it just takes 5 or 10 minutes to build this thing. You could literally whip that up while someone's sitting right in front of you and just amaze them and show them what's happening. And never forget, what's really going on here is you have an invisible magnetic field down there, and then you have this battery sending electric current into that field, and anytime you have electricity flowing inside of a magnetic field, there's going to be a force pop up, and in this case that force is pushing the wire, you know, both sides of the wire in different direction, and that's causing the turning motion. Learn anything at mathandscience.com. Today we're going to learn how to make invisible ink. I mean, who doesn't like to write invisible messages to somebody that only they can read? Now, there's lots and lots of ways to make invisible ink. You know, there's lots of ways you can go find out to make invisible ink. The way I'm teaching you how, I think, is pretty safe and a lot of fun, but you do need to be a little careful because you're dealing with, you know, blueberry juice and things like that that can make some stains. So you just want to be a little careful with it. But it's a lot of fun to do, and it just takes a few minutes. So all you need with this experiment is you'll need some paper, that's to write your messages. You'll need some Q-tips, and that's to kind of like a pencil you're going to use to write your invisible messages. You'll need, this is blueberry juice here, and I'll show you where you can get that in just a minute. You'll need some baking soda, and you'll need some water and a spoon. So it's very, very simple, easy to find materials. Let me go ahead and get some of this stuff out of the way, and we'll show you what you really need to do first, second, third, and so on. So the first thing you're going to need to do is to get your blueberry juice. That's something that you're going to need to decode the message, basically. Now, if you can find blueberry juice in a bottle, just go ahead and buy it. It'll work just fine. If you can't, it's very simple to make. Just go into the freezer section of the grocery store and get a bag of frozen blueberries. They cost like $1 or $2 at the grocery store. Go home, pour those frozen blueberries in a bowl, and just put like a tablespoon of water in there, just a little bit of water to keep them moist. Throw them in the microwave. Microwave for a few minutes until those blueberries are really piping hot, and you'll see on the bottom of your bowl, this juice is going to be in there. That's just the blueberry juice. When you microwave frozen blueberries, they just kind of seep out that nice purple, deep color juice, and it just goes out of the berries, and that's all you have to collect. And this is what's going to be important to use to actually decode the message that you're going to write. All right, so that's how we're going to decode the message. That's how you make, you know, one of the key important ingredients to what we're doing here. Now, in order to actually write the invisible message, you're going to use baking soda. And this can literally be found anywhere. Now, in order to do it, what you want to do is just put a little bit of baking soda in here. How much really doesn't matter. It's probably about a tablespoon or so. Just kind of put that in the bottom of a little dish. And then get a little bit of water. That's what the water is for. And just put it right on top. You want to do about half and half. So about however much baking soda you actually put in there, go ahead and put about that much water. And what you want to do is stir it up and make sort of a slurry out of it. So we're stirring that up. And so what you're doing is you're taking that baking soda and you're dissolving some of it. So once we're done with that, we have a piece of paper here. And so what we're going to do is turn this paper sideways to make it a little bit easier to read. And grab a Q-tip. Your Q-tip is going to act like your pen in this case. And so what you're going to do is sort of swirl it around, get the good water on there and some of the solids that are in there, kind of dip it off. You don't want to put too much of this stuff. You don't want to goop it on there because the paper has to dry. So there's no reason to goop it on there. And just write a little message. Could be something very simple. You know, I'll do this. And I'll do this. You know, and I'll be creative and just sort of draw like a squiggly line under it. So I have an invisible message. Unless you have very, very good eyes, it's going to be tough for you to see what this is. And what's going to happen is if you let it sit to dry, it will be almost completely invisible. So we'll set that to the side, and I will pull over here a message that I've already created just a few minutes ago using the same exact technique, nothing different, but this one's been allowed to dry. So you really can't see it on here. But what we're going to do is we're going to take our little indicator solution and we're going to kind of just sort of take a Q-tip. You could use a Q-tip, you could use a sponge, you could even use your finger, and we're going to basically take that message and sort of see what it says. So what you want to do is just kind of swirl your Q-tip in there, get some nice indicator on there. Again, not too much, you don't want to goop it up too much. And let's just gently go back and forth and see if we can see anything. And look at what we have here. We'll go here, we'll go a little bit down. That looks like an H. And then over here, that looks like an I. And that looks like an exclamation point. And what do we have underneath? Do we have anything underneath? Let's see. We just have like a little line underneath. There you go. And you can keep going to the rest of the page and just see if you can see anything else. And it looks like that's about it, because what you're looking for is that kind of like that dark green color. So there is a hidden message. You can't see it, you know, whenever the paper is dry, but as soon as you put the kind of decoding liquid on there, it'll stand out. Now, if you let this paper dry, then it'll be, you know, permanent and you'll be able to see it. So it's not going to disappear again. You'll have this just to kind of hang on the wall or whatever, just sort of to watch. Well, the question here is, how does this actually work? And in order to answer that question, we need to know a little bit about what we were using to put on the page. And so what we have here, we wrote our message with baking soda. Baking soda is what we call a base in chemistry. Now, this blueberry juice, you may not have realized, is actually an acid. There's an acid inside of this blueberry juice. And the exact details of what an acid is and what a base is really aren't that important for this, but suffice to say, acids are in lots and lots of things that you have around the house. Vinegar is an acid. You know, inside of lemons is a type of acid. Inside of berries like this is a type of acid. So there's acids in lots of different fruits, right? Things that have base in there, those would be things like milk. Those would be things like baking soda. So the exact chemical makeup doesn't really matter for this particular little experiment, but basically what you want to just know is that acids and bases are basically opposite of one another. They love to react chemically with one another. And so whenever you have a weak acid and a weak base like this, in this particular case, whenever they're combining together, it basically changes the color a little bit. And that's what we found on this page. Originally, everything was invisible, and then as soon as we put the indicator solution on there, which is the berry juice, we had a chemical reaction between the base, which is the baking soda, and the acid that's in the juice, and it changed colors. And that's why it only changes colors in the places where we put the base on the paper, which is the baking soda. So it's a chemical reactions. It's a great introduction to chemistry for anybody out there who wants to learn about it, because it's practical, it's something fun. And the only real gotcha with this experiment, is that you have berry juice, so you have to be a little careful, only because it can stain the carpet. So if you spill it, you're gonna be cleaning it up for a little while. So just be a little bit careful about that. Do this in the kitchen. Do it in a safe place. I'm Jason with scienceandmath.com. I hope you've enjoyed this. Go grab these materials. Baking soda, almost everyone has in the house. Paper, Q-tip, everybody has that in the house. The berry juice is something you might have to go to the store for, but you can easily go to the frozen section of the grocery store and grab that and make this in just a few minutes. And it's actually a lot of fun to do, to show people how you can make invisible messages, let everything dry and set up, and then decode that message and watch it kind of appear before your very eyes.
Learn anything at mathandscience.com.
Today what we're going to do is build a very simple lava lamp. And the reason I'm putting lava lamp in quotations is because it's not a real lava lamp, but it's a really fun experiment that looks sort of like a lava lamp, and it's very, very simple to do. What we need for this experiment is we need some sort of vegetable oil that you can find in your pantry. We need some sort of glass. Here I sort of use like a milk bottle, but really any glass from the kitchen is going to work great. You want some water. I have a bottle of water here. You just use tap water if you like. Some salt, doesn't matter if it's sea salt, just regular old salt, and some red food coloring, because most of the time we look at these lava lamps and they're red, right? Now a real lava lamp works because you plug the lava lamp in the wall and heat goes into the container, into the liquid, and it starts to carry the stuff up, and then it cools off, and then it comes down, and it gets hot again, and it goes up and down and up and down. That's called convection. So the way a real lava lamp circulates, it's basically because heat is going into it. It's causing it to go up and down in a circle like that. Now we're not doing anything like that here. We're sort of making a pretend lava lamp that's much safer to do, but it kind of looks the same. And there is some science behind what's going on here that's really neat. So what we're going to do is get some of the stuff out of the way and kind of get ready to set this up. So what you need to do is just sort of grab your bottle there, and we want to go ahead and put some water in the bottle. So let's go ahead and just sort of fill up with water. How much water do you need? It's really up to you, but I like to put at least 4 or 5 inches of water in there if I can do that. So I'll go ahead and do something like this. And also a tall glass probably is going to work a little bit better for this guy. So that's fine, that's a little bit. You want to leave some space at the top because we're going to need to put oil. Now before we put any oil in there, the next thing you want to do is put your food coloring in. So here is our food coloring, usually just a couple drops. I'll try 1 drop, let's see what that looks like. In fact, that's just kind of neat to look at by itself, just the way the food coloring sort of starts to spread out. We can give it a little swirl, right, just to kind of see. And that's not quite red enough. I like mine a little bit redder, like real lava, right? So we can go ahead and do that. Let's go ahead and put a couple more drops. So I think overall this is 4 drops of red food coloring in there. All right, you really don't want to make this too dark because it's kind of hard to see what's happening, but nice red color is good. I'm going to put the top on here and just kind of give it a little bit of a swirl. Like that. So that's a pretty good color for a lava lamp, I think. All right, so what we're going to do now is put our oil on top. So let's go ahead and take our oil. How much oil do you need? You really don't need that much oil. Maybe a centimeter or 2 on top. So just go ahead and pour the oil right on top. Something like that. Nice little layer. So what we have here by itself is already kind of neat. We have a bottle of water that's tinted red, and we have some oil on top. Now, of course, oil is less dense than water, which just means that for the same amount of the stuff, it weighs less. So because of that, it floats to the top. So we have oil on top, water on the bottom. They're not going to mix too well. Now, what we need to do next is take our salt. And you want to open the salt up so that you can pour big clumps in there. It works okay if you just sprinkle salt in the salt shaker, and you can play with this yourself, but it works, I think, a little better even if you kind of pour some good clumps of salt in there. So what we're going to do is go ahead and put the salt in and just kind of watch what happens as the salt sinks to the bottom. It's going to sort of look like a lava lamp, and then we'll talk about what happens. So let's go ahead and sprinkle some nice clumps of salt in there. Okay, now let's watch. We sort of have some sort of lava lamp action going on here. We have nice bubbling up coming from the bottom. Now at first you may not know what's causing this, but if you get down here you can sort of see that the oil is kind of trapped down here in the salt. And if you look at it long enough, you'll see the guys floating up to the top. And when the bubbling sort of stops, you can even just add a little bit more and the process can continue. So let's go ahead and add a little bit more, kind of goose it really good. And let's take a look at it one more time. Now even after the salt is already in the bottom, you can see the oil is kind of just bubbling up ever so slightly from the bottom of there and just kind of floating its way back up to the top. So the question here is, what is causing this? Why is this happening? I mean, you kind of sit there, everything's done, and you can kind of see these bubbles of oil looking sort of like a lava lamp coming up to the top. What's actually causing this to happen? Well, what's happening here is we have the water on the bottom, which is tinted red, and we have the oil on top, which is floating on top. We've talked about that. Now, when you pour a clump of salt on top of this oil, salt is heavier. If you notice, salt is heavier than that oil, or it's more dense than that oil, so it sinks. So it basically goes directly through the oil and into the water, and when it gets into the water, it sinks to the bottom of the water as well. But what happens is, when you pour the salt on top of this oil, it kind of grabs the oil because it's sitting on top of it, and it pushes the oil down through into the water. And it carries the oil all the way down to the bottom of the container. And then once the oil is trapped at the bottom, it just kind of sits there. Now what happens is when the salt gets in the water, it starts to dissolve. So what's happening here is the salt is starting to dissolve in the top layer down here in the very bottom. And once a little bit of it dissolves, it frees up that little bubble of oil that it carried down there. And then that bubble of oil can kind of come back up to the surface. So it's not a real lava lamp. It's not really working with heat. But it kind of looks like one because it's causing the oil to kind of float from the bottom of the glass up to the top. So again, what's happening is you put salt on there, it kind of traps the oil, pushes it down into the water, and so you have a trapped bubble of oil at the bottom of the glass. And then as soon as the salt dissolves a little bit, it releases those bubbles, which are then able to come back up to the surface. And so you can just keep doing it as long as you like. If you'd like to try a little sprinkle, you can try that too. And sometimes that'll work. You see, it's sort of trying to push it down there, and it does work a little bit. But you get better results if you kind of goose it and just let it do its thing. So it's dragging that oil down to the bottom, and then it's starting to release those bubbles as the salt starts to dissolve. So there's a couple lessons going on here. Salt dissolving in water is one of them. Salt being more dense than oil is another one because it's allowing the oil to be trapped and brought down to the bottom. And then once that salt is dissolved at the bottom, that oil wanting to float back to the surface is basically caused because it's less dense than the water, which means it weighs less for the same amount of the stuff there. That's what density is. So I'm Jason with ScienceAndMath.com. I hope you've enjoyed this little experiment. Very, very simple to do. Go grab yourself some water, some food coloring, some oil. And although it's not a real lava lamp, there's some real science behind why it's doing what it's doing that you can learn from. And so I hope you do that. Go do it yourself. Grab an adult, let them help you with it, and learn about mixing and dissolving, learn about density and floating, and you can make yourself a nice little lava lamp at home.
Learn anything at mathandscience.com.
In this experiment, we're going to start to work with dry ice, and we're going to use it to create dry ice bubbles. So there's a ton of stuff to learn in this experiment, and it's really fun to do and pretty easy to do actually. But we're working with dry ice. Dry ice can be dangerous, so you have to do this with an adult if you're a youngster, and you just have to get permission because dry ice can actually hurt you, and we'll talk a little bit about why that is in a second. But first, let's get to the actual experiment. What you will need for this experiment is some dry ice, which is, just so you know, frozen carbon dioxide. You can get dry ice at most grocery stores, and sometimes in the butcher department, sometimes it's in the front of the store. Just ask around, but this is usually sold in the grocery store. You'll need some duct tape. You will need some clear plastic tubing, and you'll see what that's for in a little bit. You'll need some kind of fitting that you can plug into this plastic tubing, and we'll talk a little bit about that later. You'll need a 2-liter bottle, just an empty 2-liter bottle. You will need Dawn dish soap or some kind of dish detergent because we are going to be blowing bubbles. And you'll need some kind of tongs to help us out with this experiment. And you'll also need, obviously, safety glasses because this is kind of a, you know, I don't want to say it's dangerous, but you need to be careful with dry ice. And also you might need some mittens also when we're working with dry ice as well. So as you can see, there's not too many things really to this experiment. There's the dry ice, there's the tubing, there's the 2-liter bottle, and a few extra things like tongs. One thing you do not want to forget is to put your safety glasses on when dealing with dry ice. So let's take and put some of this stuff off to the side because we're going to use some of it here in a little bit. So I'll put the soap over there. I'll put the dry ice front and center for you here so we can see it. And we'll use the duct tape here in a minute as well. Before we actually do the experiment, which is blowing, carbon dioxide bubbles or dry ice bubbles, we want to talk a little bit about what this stuff actually is because it's interesting, it's fun, and also because it's, it can be dangerous. Just like anything can be dangerous, but once you know how to handle it, once you know what it is, you are well protected. So what is this stuff? It looks like ice, and it's called dry ice. But in fact, it's quite different than any kind of ice that you have in the freezer. In your freezer, you have frozen water. That's what we call ice. When you take frozen water, it's at 0 degrees Celsius. If you add heat to it, it melts into liquid. If you add heat to the liquid water, it boils and becomes vapor, gas, right? So 3 states, solid, liquid, gas for regular old water. Now this stuff is carbon dioxide. So that's the gas that you breathe out whenever you exhale, carbon dioxide. If you take carbon dioxide and put it in a super cold freezer, eventually it will cool down and it will become solid, like these guys right here. So these guys are solid chunks of, look like little ice cubes, but they're actually frozen gas. Now if you kind of notice, a little bit, if you kind of look down at it, you might see a little bit of smokiness going on here. It's not really smoke. What happens is this stuff is really, really cold. It's much colder than regular ice. And just to give you an example, regular ice is 0 degrees Celsius, right? This is negative 78 degrees Celsius. So if this is where ice is, at 0 Celsius in your regular old freezer, you have to take carbon dioxide 78 degrees lower than that in order for it to freeze. So the reason it's dangerous, so to speak, is not because it's poisonous, it's just because it's so cold. If I get my fingers and start playing with this stuff and start trying to grab it and just play around with it, my fingers will actually freeze because it's colder than an ice cube, much, much colder. So I can get frostbite. I can freeze my fingertips and cause all kinds of blistering and things like that. So you never, ever, ever, ever want to touch this stuff with your hands. You have to use mittens or you have to use some kind of a tongs, which is what I'm going to do today. And you always want to wear safety goggles or some kind of protection to help you out with this. So what it is frozen carbon dioxide gas. So this is very, very cold. Now the other thing that makes it different than regular ice is that this stuff doesn't exist as a liquid carbon dioxide. See, with water, it's ice cube, liquid water, gas, which is water vapor, right? And you can go solid, liquid, gas. With this stuff, it doesn't exist as a liquid at the pressure that we live at here on Earth. So when you melt dry ice, it doesn't go to liquid, it goes straight from solid to gas, straight from solid ice cube or solid frozen carbon dioxide cube, dry ice cube, to gas carbon dioxide. And so it doesn't go through liquid. And that has a special word in science. It's called sublimation. So it's a little different than a regular ice cube. It's just the way it behaves. It goes straight to gas. Now let me kind of cut to the chase just a little bit and show you what actually happens before we blow our bubbles. I want to show you a little bit what happens when you actually put this stuff in water. So here's some warm water. Not going to put too much. Just going to fill it up a little bit. And what we're going to do is just take one of these regular size cubes here and drop it in the water and see what happens. Let me actually switch this guy around here, put this guy right over here, and we'll put this guy right here. So let's grab one of the medium-sized cubes, drop it in there. And you can see that what happens immediately whenever you put it into water is it starts making this fog-looking stuff. it starts making this Halloween looking stuff. So what's happening here is we're putting this very cold dry ice directly into a warm liquid, because I have warm water here. And so what's happening is the solid carbon dioxide is going straight from solid straight to gas. It's melting, basically. Just like if you take an ice cube and you put it in water, it melts. But ice goes from solid through liquid, and then if you heat it up some more, it goes to gas. Dry ice doesn't go to liquid. It goes straight from solid to gas. So that's why we see all the gas here. Now, if you kind of swirl your fingers around the gas, it feels a little bit cool. That's because the stuff is really cold. The dry ice is actually very cold in there. And what you're seeing here is carbon dioxide. Now I want to make sure you understand, the fog you see, the white puffy smoke looking stuff, that's not the carbon dioxide. Carbon dioxide's invisible. I mean, think about it. You breathe it, right? So when you blow out, and you breathe in, you blow out again, you don't see the carbon dioxide. That's invisible. But the carbon dioxide, when it comes off of the dry ice cube, is so cold that that cold carbon dioxide gas is condensing the water in the air. And that's the cloud you see. So the visible stuff, the cloud-looking stuff, that's water vapor that's condensing, that's in the air. The carbon dioxide itself is very much odorless and invisible, and you can't see that. So you're seeing a mixture of the two here. Now what's going to happen is if we leave this here long enough, you can see the cube still down there in the bottom, bubbling away, it's going to eventually disappear. It's going to go from a cube, it's going to disappear because all of that carbon dioxide is going to leave. Now it makes for some really fun effects because you can make these nice fog effects, and what we're going to do is use this to basically try to make some dry ice bubbles, to fill some bubbles up with this guy. That's the point of this sort of experiment here. So let me go ahead and move this over here and move my dry ice back where we started. And what I have here is a tube. This is a flexible plastic tube. It's clear. You can buy this at the hardware store. It costs a couple dollars. And I have a fitting here. It doesn't really matter what kind of fitting. I just wanted something I could wedge into the bottom of this and to give me a little bit of a wider opening. So I'm going to stick this in here. I'm just going to wedge it in there. The only I'm going to blow my bubbles out of the end of this, so I just want to have it a little bit larger. So imagine you kind of blowing on this end here, then bubbles are going to sort of pop out the other end. So the next thing we need to do is make our bubble solution and figure out how we're going to channel this smoky carbon dioxide water vapor mixture into our bubbles to make these really cool bubbles. All right, so the next thing we want to do is go ahead and make our soapy mixture. This is what we're going to blow bubbles with. So we'll take our dish soap and we'll just put sort of a healthy amount down on the bottom. And then what we'll do is we'll take some of our water and we'll just sort of make, just like you would blow bubbles, you know, with a bubble wand, we'll make like a little solution of that and see if we can get that to make bubbles. So what we'll do is we'll just use our little finger here to stir this up. There's nothing dangerous here. It's just water mixed with dish soap. Now you may have to play with the mixture here. You might have to play with the amount of soap that you have in order to blow some good bubbles. Now to go ahead and test it, all you do is stick it in the end there, kind of wiggle it around and blow a bubble. And we can see that we're making bubbles, so we're doing good. So we'll go ahead and put this off to the side. And the next thing we're going to do is create a way to channel this dry ice carbon dioxide into our bubbles, right? So that's what we need to do next. So what we're going to do is we're going to drop our dry ice in here. And so we need some water. So let's go ahead and put this water in here. Now this is warm water. It's not super hot. You don't want it to be super hot. You want it to be nice and warm. And you want to fill it up about halfway or maybe a little bit more. So this is about where we want it. We want water that's nice warm water, not too hot, not too cold, in about 3/4, 2/3 of the way up this bottle. Now what we need to do is figure out a way to connect our bubble blower with this. And I have a saying that in the house that duct tape can be used for just about anything, and that's what we're going to do here as well. So let's just sort of grab a nice bit of duct tape. It doesn't really have to be, you know, too tight. It just needs to be tight enough to secure this hose into the top here. So this guy's going to go in here and we're going to tape it in place. But before we actually do that, we want to get the dry ice in there and ready. So we're going to have that set aside. We're going to put the dry ice right over here. And now we're almost ready to go. We have our dry ice, we have our bottle, we have our bubble solution here. And what we're going to do last is put a little rag out. You don't want to get a nice towel, you just want to get a nice little rag that's sort of beat up and something you don't care about. Basically, when you blow these bubbles, the bubbles are going to want to stick a lot better and not pop if we kind of let them land on this little towel. So that's why we put that there. All right, so we're about ready to go. What we're going to do is we're going to drop some dry ice in here until we start to see a nice cloud form. Then we're going to stick our tube in there and duct tape it. And then we're going to start to submerge into the bubble solution and go from there. So I have a lot of dry ice here. Some are too big to fit, but I have these nice little pieces. You can kind of break it up with a hammer and drop one in there. So we'll just kind of go one at a time. You can see some are easy to fit and some aren't. So I'm just going to drop a few in there until we have enough where I think we can actually start blowing some bubbles. Okay, so we have 3 or 4 bubbles of dry ice, blocks of dry ice in there. You can see that they're rapidly releasing carbon dioxide, which is coming out. It's hitting the water vapor in the top of this guy and condensing it. That's the cloud you see. And now we're ready to actually start to try to do this, guys. So let's take our tube. We'll just put our tube in there, and we'll just take some duct tape and just make a nice little seal to force the majority of this gas to go out here. And I'm going to put one more piece just so we don't lose anything right off over the top, just like that. Again, it doesn't have to be really tight because you're not really putting a lot of high pressure through here, just trying to channel it. So what we're going to do next, and you can see we have our little gas coming out there. We're going to put it in there and start to blow some bubbles. And there is a dry ice bubble. We'll bounce it off, and it popped there. Let's see how big they can get. Let's just kind of hold it there and just see when it's ready to let go. And I'm going to try to let it drop down into the little soap that's dripping down above here and see if it'll detach. Almost. But you can see these bubbles are full of this this carbon dioxide gas with water vapor. There we go. So we want to tilt it to the side a little bit, and we can get them to detach and kind of land on our towel a little bit. All right, and whenever you're done looking at them, you can just touch them, poof, and there it goes. See if we can get one to stay. Sometimes they say, sometimes they don't. So basically that's what's going on here. We're taking the dry ice, we're causing it to sublimate inside, and we're channeling the carbon dioxide plus the water vapor through a tube and into some bubbles. When you're done looking at them, you can just pop them. 1, 2, 3. So it's a lot of fun. Just make sure whenever you do this that you don't cap off your bottle, that you have to have a place for the air and the carbon dioxide and the water vapor to get out so you don't build up dangerous pressure inside of this bottle. And now we're going to have a grand finale for these blowing of these carbon dioxide bubbles, or these dry ice bubbles. So before we had sort of the little bubble wand blowing small bubbles. Now we have a large bowl with warm water inside and a lot more dry ice. And what we're going to do is try to blow a bubble with the entire bowl. So here are some large pieces of dry ice. Notice what happens when I put them in. Lots and lots of action. So we'll put that in there. We'll put some more. Immediately starts to bubble. Put some big chunks in there. Something like that. All right. Now I have a piece of a rag that I've cut here. And what we're going to do is sort of put that into our bubble solution. And what we want to do first is we want to kind of get some nice bubble solution right along the edge, along the lip. We want to hold our rag out kind of flat. This is a little bit messy here. I promise it's worth it. And we'll just go around the edges, dragging this bubble across. Now you can see we formed a bubble right across the top of the bowl, and it's getting larger and larger, the pressure increasing inside from the gas that's coming up. Eventually it'll pop and should spill right over the top. So let's check that out. You can actually get these things pretty big too, if you dare, so to speak. So here we go. It's already kind of outgrown it completely. It's so tempting to actually just pop it right now, but I'm kind of curious how big it's going to get. Now this is not going to make a mess as far as the bubble part of it goes, because what it's filled with is gas. So as soon as it pops, it's going to spill over. The water and everything is still in the bottom there. So here we have almost like a little brain. You know, let's see how big we can go. And there it goes. And it just spills right off of the top. Now that was actually cool enough where we're going to do that again. We just go from here Drag it across, create the film. Now, one tip I can give you when you're doing this, because it took me a few times to actually get this to work, do not fill the water level all the way up in this bowl because it's bubbling so much inside it pops the bubble. You want it about halfway or maybe less, and then the bubbling that you hear is not impacting, it's not hitting the actual bubble on the top. So there you go. And again, it's so tempting just to go ahead and pop that guy, but we're going to let it go one more time. I wish there was a way I could just blow it and have it float off, but obviously one thing that I didn't point out that's very important for you to understand is when we were blowing the small bubbles, notice how the small bubbles were sinking. The small bubbles didn't float away, they sink. And that is because carbon dioxide is heavier than air. It's more dense than air. Now, there's a couple things we want to talk about to understand the science here. We talked about dry ice. It's frozen carbon dioxide gas. Really cold, really dangerous if you touch it with your hands, so you never ever want to do that. When you put it in water, it starts to release carbon dioxide gas, which is really cold. That cold carbon dioxide gas starts condensing the water vapor, and that's the cloud that you see. You can wash it away, flip it away with your hands and sort of see the vigorous bubbling here. But the cloud you see is actually the water vapor. The carbon dioxide is invisible. Now, if you remember, when we were blowing our carbon dioxide bubbles, there's a science lesson in here because you're filling it with that carbon dioxide gas along with water vapor. Now, carbon dioxide is heavier than air. It's more dense than air. So carbon dioxide is going to tend to sink instead of float. So a regular bubble, when you blow a bubble, it floats away, right? Well, with a carbon dioxide bubble or a dry ice bubble, it's actually heavier than air. And that's why all of those little bubbles, after they kind of detached, they kind of just sat there. They didn't float away because inside that bubble was a gas that was heavier than air. And that's kind of what happens here as well. You notice all of the carbon dioxide is kind of staying inside of this bowl. And if I flick some of it out like this, it kind of runs over the edge and hits the table, and it kind of just hugs the ground as it goes. And that's because it's heavier than air and it wants to go down like that. So the water vapor with the carbon dioxide wants to go ahead and follow that path. So the water vapor with the carbon dioxide gas wants to follow that path. So it's heavier than air, it's extremely cold. You want to make sure and have precautions when you work with it. Always work with an adult or a supervisor whenever you're doing this. You can get dry ice at most grocery stores. It's actually very inexpensive. It's a few dollars for a big block of it. It'll keep in your freezer for a couple days. And when it melts, there's no mess. Whenever dry ice melts, it just goes into the air. So it's not any kind of pollution or anything like that. So go grab it. Go play with it, but do it with an adult and do it with some supervision and do it with some common sense. Don't try to grab this stuff with your hands because it will burn you, it will hurt you. But there's definitely a good science lesson here, learning about gases, learning about density and the fact that the stuff in here is more dense than air, and that's why it's wanting to stay, inside this container, and that's why when we billow it out, it kind of wants to hug the ground. That's an important science lesson there. And the fact that these bubbles can be blown, and whenever we blow those bubbles, they kind of sink to the ground too. So it's mostly a lesson in buoyancy and how the bubbles want to sink, along with learning about dry ice and the fact that it's frozen gas. And it does not go through a liquid phase. When you take dry ice and you heat it up like we're doing with the water, it doesn't go to liquid, it goes from solid directly to gas. That's called sublimation. I'm Jason with scienceandmath.com. I hope you've enjoyed this experiment. Go get the materials, go have fun with it, use some common sense, and learn about dry ice and blowing dry ice bubbles.
Learn anything at mathandscience.com.